Hi everybody, it's Karen Cole from Legal Minded Friends, and today I'm very excited. We've got a UK author, Marcus Chown, with us, and he's going to talk about his latest book, One Thing You Need to Know. So without further ado, Marcus, can you introduce yourself?
Hi Karen, well I'm a science writer. I write popular science books like Quantum Theory Cannot Hurt You, and my latest, which is called The One Thing You Need to Know, and I'm a journalist. But I began my life as a radio astronomer at Caltech, the California Institute of Technology in Pasadena. And when I was there, I got to be taught by all kinds of people, Nobel Prize winners, and Richard Feynman, the post-war American physicist. And I learned amazing things, and I just thought if other people knew the things that I knew, they'd be as fascinated as I am. So I try and communicate that through my books. My audience is my wife, actually, Karen, who is an NHS nurse. And so if she gets bored and she turns up the volume on EastEnders or whatever she's watching, I have to try even harder.
Well, I'm sure your wife, Karen, is a real inspiration. When I was little, I watched Lost in Space and then Star Trek. And so my fascination with the galaxies and everything was born out of those shows. And William Shatner came to our shopping center, our local shopping center. So I got to meet him years ago. And remained a Star Trek fan. Then when I attended university, I was fascinated with astronomy. So I took a course on astronomy at our university, and our campus had an observatory, which is it's just spectacular. The views of comets and other solar systems that we were able to see. So can you tell us how you first got interested in astronomy?
When I was about 8, my dad bought me a book on astronomy. It was called Dr. H.C. King's Book of Astronomy. He was the director of the London Planetarium. I've got no idea why my dad bought me that book. He'd left school when he was 15. He'd grown up during the Second World War, when schooling was interrupted, but he bought me that book, and for some reason it grabbed my interest. And then, of course, when I was about 8 or 9, there were the moon landings, and they were absolutely fantastic. I remember my dad getting me out of bed early in the morning to see those grainy black and white images of Neil Armstrong stepping on the moon, and it just completely blew my mind, the idea that a human being has actually stepped on another world. And my dad bought me a small telescope, and I from the window of our flat in North London, I used to look at the crescent of Venus and the moons around Jupiter and all that sort of stuff. So that's really how my interest got started.
So, Marcus, I also noticed that you created this iPad app of the solar system, which I will leave a short clip after for people to see you introducing it. But in your latest book, which I have right here, you discuss neutrinos and how they stream through us as if we were empty space. So can you explain or tell us a little bit about how they were discovered and what they are?
Hold up your thumb. There are about 100 billion neutrinos streaming through your thumb now every second. 8.5 minutes ago, they were in the very heart of the sun. Now, neutrinos are created by the sunlight generating nuclear reactions at the heart of the sun, but they are unbelievably antisocial, and most of them just pass through the Earth as if it's thin air. In fact, they were so antisocial that the man who predicted their existence in 1930, Wolfgang Pauli, famously bet a case of champagne that nobody would ever be able to detect them. But in 1956, a nuclear reactor in Louisiana in America, Frederick Reiners and Clyde Cowan detected neutrinos, and one of them got the Nobel Prize. Unfortunately, Clyde Cowan died before the prize was awarded. But you may think, well, who cares about neutrinos? Well, it turns out they're the second most common particles in the universe. So the most common particles in the universe are photons, particles of light, but neutrinos are the second most common. So we actually live in a neutrino and photon universe. Everything else is a minor contaminant.
And I remember in your book you quote his infamous line, "I've postulated a particle that cannot be detected," which seems to be the beginning of this challenge for scientists. And I really enjoyed the way you use visual imagery to imagine it. But can you talk a bit about the sun's energy and the heat? Because I'm fascinated with the sun. I always feel much better when I'm around the sun. And in fact, in January 2012, there was a solar flare that hit Earth, and to capture that imagery, I did a painting, which people can see on the cover that I made for us. So that's a visual that I wanted to capture. Now, when I think of the sun being the closest star to us, I can't even imagine the heat that the other stars have, or I don't know. Can you explain that to us?
Imagine your stomach and a chunk at the core of the sun the same size and shape as your stomach. Incredibly, your stomach generates heat at a greater rate. So the sun uses just about the most inefficient nuclear reaction to generate heat that's possible. On average, it takes 2 hydrogen nuclei, these are the cores of hydrogen atoms, to come together and stick, and that's the basis of the generation of heat in the sun. It takes them about 10 billion years on average to come together and stick. And it's for that reason the sun will take something like 10 billion years to burn its fuel, and therefore there's been time for the evolution of complex life on Earth like ours. And you may wonder, if the sun is so inefficient at generating heat, how come it's hot? Well, of course, it just doesn't have one chunk the size of shape of your stomach. It has quadrillions of chunks the same size and shape as your stomach, all stacked together, and that's why it's hot.
Well, that certainly makes it a little easier to conceptualize. Can you tell us a little bit about the Big Bang Theory, something that will blow our minds?
Science is also evidence-based. So we believe, for instance, that the universe was born 13.82 billion years ago in a Big Bang. So it was a very hot fireball, and out of the cooling debris, as that fireball expanded, have congealed the galaxies, something like 2 trillion of them, of which our Milky Way is one. But the evidence for this is all around us. So if you were to tune a radio between the stations, something like 1% of the static that you hear has come from the Big Bang. And the reason for this is that the fireball of the Big Bang was bottled up in the universe, which by definition is all there is. So it had absolutely nowhere to go. So the light of the Big Bang has been cooled by the expansion of the universe over the past 13.82 billion years, but is still all around us. It's no longer visible light, it's in a form known as microwaves, which are kind of what we use for microwave ovens and for our phone conversations. And incredibly, 99.9% of the photons, these are particles of light, in the universe today are tied up in this afterglow of the Big Bang. And only 0.1%, that's only 1 in 1,000 photons, comes from the stars and galaxies that we see. So this afterglow of the Big Bang is the most striking feature of our universe. If we had eyes which could see microwaves rather than visible light, we would see the entire universe glowing like the inside of a light bulb. So that's really the evidence that there was a hot Big Bang.
That is mind-boggling and mind-blowing. So in legal matters, I find critical thinking is essential in order to make judgments and decisions. Can you explain how scientists use critical thinking to form their complex theories in order to make judgments or beliefs in what is or isn't?
Scientists have a faith, a belief for which they have no real proof, that drives their scientific endeavour. And that belief, that faith, is that ultimately the universe is simple. So although it looks incredibly complex with trees and people, stars and galaxies, they have this strong belief that beneath the skin of the world, it's made of simple building blocks. And this belief goes back to a man called Democritus, a Greek philosopher in 440 BC. And he picked up a rock, or it might have been a branch or a piece of pottery, we don't know. And he asked himself this question: if I cut this in half and cut the halves in half, can I keep going on in this way forever? And Democritus thought it was inconceivable that he could keep going on forever. Sooner or later, he would come to a grain of matter that could not be cut in half. And the Greek for uncuttable is atomos. And so he came up with the idea of the atom, the indivisible grain of matter, simply from pure thought. And he didn't stop there. He thought that these atoms would come in a handful of different types. And it would be by assembling them in different ways that you would get a baby or a pot or a table or whatever. So basically, everything's in the permutations. Ultimately, the universe is very simple and everything is in the permutations. And incredibly, we now know that everything around us, everything in the universe, is actually formed from a combination of just 3 building blocks. They're called the up quark, the down quark, and the electron. So Democritus, all that time ago, was correct. But this idea that the universe is simple underneath really does influence all science.
This is fascinating stuff. Marcus, I'm sure you wouldn't remember, but I met you in Cheltenham many years ago at a science festival, and I heard you doing a chat on black holes and their relationship to space and time. And I noticed you devoted a whole chapter to black holes. Can you speak a little bit about your current book and how people can order it?
My current book is called The One Thing You Need to Know. I take 21 topics from relativity to quantum theory, plate tectonics to the brain, and I tell you the one thing you need to know from which everything else follows logically. You can get copies of my book and my other books from all good booksellers. You can also buy it from Amazon. But if you want to buy it from an internet seller that pays more tax, you can maybe try something like Hive. That's www.hive.co.uk. Thank you.
Well, thank you for that, Marcus. Definitely, if you type your name into Google, loads of stuff will come up. I'll leave a link to your website for people, and I really hope they check out your latest book that's just come out. It's in a lovely hard cover, which is always nice to put on the shelf. I believe you told me that the book is available now in the UK. Obviously, I got a copy. And it will be available in July in America. So he has... Everybody, please check out his books. The way he describes science, and it's really easy to read. All the chapters are nice and short. But one thing I really like is there's a glossary. And there's also an index. Really does make a difference. So the other thing I'd like to tell you is that Marcus also writes some books for children. And I'd like to leave you with a short clip of when Marcus Chown had developed the solar system for iPad when it first came out.
My name is Marcus Chown, and I'm the author of Solar System for iPad, which is essentially an interactive book You can navigate it in many different ways. The most fun way is from the main screen, which is pretty much like a chocolate box full of planets and moons and asteroids. So let's go, for instance, to Mars. So I just click on the image of Mars, and what comes up is a short introduction about Mars, plus a three-dimensional image of Mars. And we can zoom in and out on this image, and we can spin it, and we can tumble it north to south. And we can also click through stories about Mars. What I really like is this story here, which has next to it a 3D animation of you actually flying down this canyon on Mars. This is tremendous canyon. It's so big that individual tributaries are bigger than the Grand Canyon. It's been compiled, this simulation, from data gathered by satellites in orbit. Another thing we can do with this book is we can look at galleries of images. Each of the objects has a gallery of images. So if I click on the gallery here for Mars,
I'll leave a link to the full clip as well if you're interested in watching it. And then I'll also leave you a link how to order, how to download the Solar System for iPad, the latest version. It's not very expensive. I think it's under £15, so it's really reasonable and very educational and informative and fascinating. Well, I hope you found today's video interesting, and information is power. Why not subscribe and watch more of our videos? If you need legal help, contact Legal Minded Friends.